Welcome back to my channel, Statistics for Applied Linguistics. I'm Dr. Marnie Menegra, and in this video, we are going to look at the effect size. So the big question is, what is the effect size? So the effect size is something that you can calculate before you do your hypothesis testing to see what your sample size should be. We often don't get the chance to do that. So we'll often look at the sample size after we do the hypothesis tests. And we're going to calculate the effect size with our parametric tests, which would be Pearson's correlations, t-tests, and ANOVAs. I have a different video on which t-test to use, and when we go live in JASP for the different types of t-tests for those 3 different videos, you will see that I'm going to include the effect size, which is called Cohen's d. For the ANOVAs, when I do the videos showing the different types of ANOVAs in JASP, you will see me include the effect size, which is eta squared. For Pearson's correlation, the line of R is our effect size. So again, what is the effect size? We know that we're going to use we're going to report the effect size with our parametric test, but what exactly is it? Well, the effect size, when we look at the statistical significance, so when we complete a t-test or an ANOVA, we're going to find whether the results are statistically significant. That means the p-value is less than 0.05. And this shows that an effect exists. However, statistical significance can be influenced by the sample size. So the effect that we find with statistical significance, if we only have 30 participants, the effect could be different if we have 50 participants or 100 participants or 150 participants. So a practical significance shows that the effect is large enough to be meaningful. So when we calculate the effect size, then let's say if we have 30 participants and we have a p-value of less than 0.001 with a large effect size, then we know that if we have 100 participants, the effect size is going to be the same. So the effect size tells us how much the groups overlap. So in this diagram here, you can see that a small effect size, we can see that there is quite a bit of an overlap. Whereas when we get down to a very large effect size, the overlap between the 2 groups is quite small. So the effect size, different parametric tests use different calculations. So for Pearson's correlation, we're going to use R, and a small effect size would be 0.1, medium 0.3, and large 0.5. For t-tests, we use Cohen's d. A small effect size for Cohen's d is 0.2, medium 0.5, and large is 0.8. And for ANOVAs, we use eta squared, which is the treatment of the sum of squares, divided by the total of the sum of squares, and a small effect size is 0.01, medium is 0.06, and a large is 0.14. So this is from Cohen in 1992 in the Psychological Bulletin. And so when we look at the t-test to calculate Cohen's d, and you'll see this in the individual videos, you're simply going to click on the box for effect size. So here we've got a box for effect size in JASP. And then we're going to look at Cohen's d, and then we would go back to the chart and report based on this line if it is small, medium, or large. So this is the formula for Cohen's d. If you needed to calculate it by hand, you're not going to need to do that in JASP. But for eta squared, if you're calculating for an ANOVA, here you're going to come down and estimates of effect size, click on eta squared, and we've got eta squared right up here. And then you're going to go back to the chart and report whether the effect size is small, medium, or large. So we're going to do this at the end of our parametric test. You'll see the effect size shown in other videos when we go live in JASP. So this is the end of the introduction to effect size and what an effect size is. Thank you so much for watching this video, and I look forward to seeing you in the next video.